Okay, hello everyone. Welcome to a design review meeting about incremental language development for Wolfram language. And we have a number of topics today. All right, first up, we have FindEquationalProof and ProofGraph. All right, so what this is about is the story of updating the output from FindEquationalProof. And the main thing here is how do we make some of these proof graphs more beautiful and more graph usable, and how do we make the output from FindEquationalProof more reusable, which I think is part of the story of our whole multi-computation thing. But maybe we could start off with, I don't think we have anybody from design here, so I'm not sure quite what, actually I have two questions. So Nick, I think you had, some part of this is axiom to tautology, which is the usual FindEquationalProof story. But I thought you had a method now for going from axiom to theorem in at least many cases. Is that true?
Well, this is the one below, when you just apply reverse.
So what does that mean? So you can go, so there's the axiom, and then there's the theorem at the end.
Yeah, but it also creates like an additional axiom, which is another small green circle there, which is a tautology.
So I see. So it has to create an additional axiom in order to turn the thing around like this. Is that what you're saying?
Yeah.
Can it always be turned around like this?
Well, maybe not, but it depends on what actual proofs are there. But in most of the cases, I think it is.
Let's see, we have Jonathan here, and he probably, as the creator of FindEquationalProof, he might have an opinion about this.
Right. I mean, so what you're asking is how often can you rewrite proofs that are done in the resolution format in something more akin to sequent calculus? And obviously the answer from logic is sometimes, but not always.
But in the end, something which is true in one case will be true in the other. Is that not correct? I mean, in other words, they are ultimately equivalent, but it's not obvious how complicated the transformation is from one to the other. Is that right?
It's a little bit more subtle than that.
Can you say what the
story is? Sure. So proofs so the relevant notion with regards to resolution theorem proving is not logical equivalence, it's equisatisfiability.
Explain. So if you're saying, wait a minute, so normally this is going to prove a tautology, which is of the form thing equals thing. Isn't that right?
Yes.
Okay, what is equisatisfiability?
Well, so as I say, the transformation steps in resolution theorem proving are not guaranteed to preserve logical equivalence. They're only ever guaranteed to preserve equisatisfiability, which is all you care about from the point of view of theorem proving. So two propositions are equisatisfiable if it's the case that, if there exists a model for one, there exists a model for the other.
Okay. As opposed to what? As opposed
to logical equivalence, which is what you said.
What's an example where they're different?
So in general, anything where you introduce Skolem variables is going to, like, the Skolemized form of an expression is not going to be logically equivalent to the original, but it will be equisatisfiable.
Okay. And
whereas if you're building up constructively, you're always guaranteeing you're always guaranteeing logical equivalence.
Okay. So,
and in general, it's cleaner to prove things by the resolution method than it is to prove things kind of constructively.
But the resolution method is fundamentally turning it into a tautology. Is that true?
Yes.
And okay, I mean, the thing is that for other purposes of, find replace path and things like that, what we're interested in is more initial condition to final state, rather than this case that is more specific, I think, to theorem proving of generating a tautology. Does that make sense? I mean, that's why I'm interested.
Find replace path a little bit different. Is when you go from the left-hand side to the right-hand side. It's like.
Well, fair enough. Okay, but so. Okay, look. The first question is, the first question is purely a cosmetics question of, I think these graphs look kind of nice, there's a question of if we give more detail and we actually show the formulas, we could also show the actual, well, now what's happening here? So these are equations and these are events that combine, which have the property that they take two lemmas in and produce one lemma out, right? And in this particular case, the size of the blob is proportional to the leaf count or something of the underlying expression, right?
Yeah, right.
Okay, but so one thing that's nice here, now in the current FindEquational proof formatting, we have dotted lines and we have solid lines. And I'm now forgetting what this, I like the fact that this is very clearly, two lemmas come in, one goes out. And that's kind of the story throughout this graph, I think.
Right, which is identical to the FindEquational proof graphs.
Okay,
just
but so
graphs have the additional information about what the lemma was actually used for. Was it used as an input or was it used as a construct?
What does that mean? What is the difference between those two?
You can either take a lemma and apply a rule to it, in which case it's an input, or you can take a lemma and you can generate a rule from it, in which case it's a construct. So in general, a substitution lemma will have one input and one construct. Inputs are shown with solid lines, constructs with dashed lines. A critical pair lemma two constructs.
Sorry, so what do you say about critical pair lemmas?
A critical pair lemma will have two constructs because, of course, for a critical pair lemma, you want to show an overlap between left-hand sides of rules, and there's no input for a critical pair lemma.
Okay, but in FindEquational proof, as here, there are two inputs for every event, correct? Two inputs and one output for every event.
Yes.
And part of the goal here,
well, not necessarily. Well, okay, yes, no, yes, true.
But in FindEquational proof, so one of the things we're losing here is the information about which of the things coming into the substitution events, which one is the sort of applied lemma, and which one, in other words, these are not symmetrical. What we're now calling bisubstitution or critical pair lemmas are symmetrical. The two inputs are symmetrical. Is that correct?
Yes.
No. What do you mean symmetrical? No, they're not symmetrical.
It doesn't matter which one is which. There's no, or does it? I
No,
thought
we can make the similar distinction by just like enumerating one of the input edges, as one of them can be dashed, as like to indicate that it's a construct.
No, but I don't understand. What in the case of bisubstitution, aka critical pair lemmas, what is it the case that the two expressions enter symmetrically? They don't in the case of a substitution.
There is still like a rule that you're acting on and the rule that you're acting with. It's just you can make all circles red, but you still have this orientation, this distinction.
I see. Well, so in FindEquational proof, let's look at the corresponding FindEquational proof here. Oops, we want to say that comma proof graph. Okay, so there are a couple of differences here, and I'm not sure whether we, one difference is that in this case, we're showing the intermediate expressions, whereas in this case, we're just showing the events. Is that right? So for example, in this case, that event, so where is that event here? I mean, I'm a little bit confused. So that's A dot A equals A is the output from that event. Is that correct? And that's what that means, yes? Substitution lemma 2.
Yes, yes.
Okay, so then, for example, that would be, it's kind of weird. Why is substitution lemma 2 so hard to find here? Oh, maybe that's because it was turned around in this case. When I go on a voyage of discovery, trying to find.
They may be like changed the indices. They might not match the original one. I'm not sure.
Okay. Okay, but the transformation, I mean, one thing that's changed here is that the intermediate expressions or intermediate lemmas are explicitly shown as nodes in this graph, which they're not in this case, right?
Right.
And I mean, at least in my effort to understand this, it's helpful to have those intermediate lemmas there, and potentially to have the you know, this kind of thing, although that font is wrong, but you know, explicitly displaying. I mean, I wonder whether there's anything we can do. You know, in simpler cases, it's pretty nice to have these explicit displays of the lemmas that are produced. Arguably, in one of these events, see, this is where it gets confusing. In one of these events, we should be showing, you know, what was the actual change that was made. We have to have a representation of the actual transformation, as FindEquationalProof does. Am I making sense? I mean, so if I say proof dataset, we should have that representation there. Yes. I mean, the difficulty is the reusing the stuff from here is, I mean, you know, that's been the challenge, but we haven't had things which need to reuse it, which we now do. So it's like, how do we get out the right? I mean, this is perfectly nice what it has. I'm just, you know, the question is, what is the next step here in terms of
sorry, I'm trying to understand this. So in this new representation, each new lemma is preceded by an event. Is that correct?
Yes.
So each per lemma event is what we represent in the traditional form on the right.
That is correct.
Yes. And what's the advantage of separating the lemma from the event?
I don't know. It's easier for, I mean, for me, it's been easier to understand. I mean, I'm not sure that, and it maps more closely onto our kind of token event graph formalism.
I see.
But I mean, we should provide both, right? Mm-hmm. We should provide both. And I think also, you know, I think this graphical, the graphics look a little bit nicer than these do.
Yes, that I agree.
But Jose, to answer your question, graph theoretically, all that you're doing is you're taking each lemma node and you're splitting it into two vertices, one which has the first which has out degree 1 and the second which has in degree 1. Mm-hmm. And nothing else has changed.
And I mean, one of the issues, you know, so in this graph, you know, we're seeing perfectly nicely in tooltips. Yeah, I'm not sure we can resolve this in this meeting. I think this relates to a bunch of stuff about, you know, our representation of computations. Because essentially what we're doing here, you know, this is an example of where we're representing a computation. We're saying, you make this transformation, we're explaining here, you know, what is the position in the input, presumably, at which this substitution will be made. Is that right? At which this rule will be applied from left to right. Is that correct, Jonathan?
Yep.
Okay. So I mean,
the rest of it, but that
which rest of which?
The previous discussion.
Which part?
You said that the proof graphs don't have a representation of intermediate lemmas, and you and Nick also said that in critical pair lemmas, there's still a distinction made between input and construct.
Okay, so it was my understanding there wasn't such a distinction, that critical pair lemmas was symmetrical. Is that not correct?
Well, it is correct, but
okay.
So that's what I'm not understanding.
Okay, fine. Okay, so, but here what you're doing is you've got dotted lines that represent the lemma input, the operating with part of the substitution is a dotted line, and the operating on part is a solid line. Correct?
Right.
Which is a nice convention, and arguably, I mean, these graphs are, a huge step up from anything that existed before, but I think we can do even better graphically. Okay, so that's one issue, is probably we need two colors of two ways to represent these edges here to correspond to these dotted versus non-dotted ones. I'm not quite sure that dotting, and then, but the thing I was more saying is, what we're doing here is it's the same thing we've been discussing for other purposes. We have the we're representing where a replacement took place. Am I making sense? Which you're doing here like this. But there's the more general problem. If we just have a find replace path or some such other thing, there's the how do we report where the replacement took place? In general, how do we report what was done in this transformation? And that's what some of the rest of our discussion is supposed to be about. I think we should, I'm not sure there's more to discuss here other than the graphics of this, which I think in the end, what we're going to want is a refresh of this graphical appearance, and then an additional, I don't know what we should call it, this graph here. We could call it a token event graph, I suppose, instead of a proof graph. I don't know. Anybody got any thoughts about that? And then, I think we're going to want a version in which we do actually display in some form the actual expressions as part of the proof graph. Because, traditional automated theorem proving, people have not been that interested in what's inside the proof. We're getting more interested in what's inside the proof. And I think, so Jonathan had also explained, so Jonathan has a different way of doing Skolem variables here with that light purple color, if I remember correctly. Is that right?
Exactly, yeah.
And what Jonathan was saying is that this kind of untangling from axioms to theorem can be done when they're not Skolem variables. Was that right? Is that it can be uniformly done in that case? Is that true?
I don't think what I was saying is not quite that strong. It's just that Skolemization is one place where I know that can fail, where it's known that Skolemization does not preserve logical equivalence. But I believe there are other cases in resolution theorem proving for which that's true as well. The point being that resolution, unlike what you're describing, which would be more like sequent calculus, resolution theorem proving doesn't claim to preserve logical equivalence. It only ever claims to preserve Equisatisfiability.
What does the word resolution mean in the term resolution theorem proving?
So as in reduction to a tautology, to resolve an expression is to reduce it to a tautology.
I see. Okay. And whatever, so Jonathan, in your high-tech proof-to-proof transformation theory, is that operating? So that would operate on these graphs using I mean, you have a collection of transformation rules which are somehow proof correctness preserving. Is that correct?
That's right, yeah.
And if I'm to think about that, I mean, here we're taking trees and we're transforming them into other trees. Is that true? Mm-hmm. Whereas for proof-to-proof transformation, you have to transform a graph into another graph. Is that correct?
Right. Yeah, exactly.
And is it obvious? I mean, is there an obvious minimal set of sort of proof-preserving transformations?
It's reasonably obvious if you play around with it a bit. I mean, like, so there are some that are very obvious. Like, clearly you can, if you have two substitution lemmas and they're adjacent along a solid edge, then you can merge them because, if A equals B, essentially because of transitivity of equality.
Mm-hmm.
And similarly, if there are substitutions, and there's for every one of these rules, there's a time reversal of it. So there's also a fission rule for substitution lemmas that lets you break them apart. That's essentially analogous to Genson's cut elimination lemma. And then you have other ones that again become obvious when you start to think about them.
Hold on. Breaking apart a substitution lemma is to say you are introducing another lemma. You're doing the substitution in two pieces. Is that right?
Right. So if you've got a substitution that says A goes to B, then you could replace it with one that says A goes to C and C goes to B, and you still preserve proof correctness.
Mm-hmm.
For some C.
Mm-hmm.
And then there are similar ones like if you've got a critical pair lemma with two substitution lemmas that come off it, then you can merge those into a single critical pair lemma if you combine their dependencies in the right way. Because if you've got a pair AB and then A substitutes to C and B substitutes to D, you can replace that with a critical pair BD as long as you handle the predecessors and successors in the right way.
So have you implemented this stuff?
Not in anything production grade, only in research code right now. But the plan is to have a function repository entry that does like we have the ZX calculus graph rewriter, to just have a proof graph rewriter.
And what do you think? I mean, do you think it is plausible that one can do a kind of, I mean, how does one know which way is better, so to speak? You've got these transformations. What is the, how do you drive that, so to speak?
So for the time being, I've just been using the old heuristic that we had for the ZX calculus diagrammatic theorem prover. Just choose the path that maximizes causal edge density, which gives you something that's a bit like a gradient descent.
Okay. Where are the causal edges here? I mean, there should be additionally causal edges between these events, right? I mean, this is a, am I mistaken? Within this event, there are pieces of this lemma that are affected and pieces that are not.
Mm-hmm.
So we could draw, on top of this graph, we could draw causal connections too.
Right.
Has that ever been done?
Well, yes.
But
in the sense, the construct lines are telling you something about the causality. Causal edges, in the sense of multi-way system causal edges, are a more fine-grained version of that.
Okay, but we could additionally, given the trees that exist at every event, there is every piece of every tree at every event. We could track its causality to other events.
Well, it gets slightly more complicated with the case of critical pair lemmas, because the expression to which the rules are being applied in a critical pair lemma may not necessarily be part of the proof graph, if that makes sense. So you'd have a notion of causality that's quite dissimilar to notions of causality that one has in conventional multi-way systems.
Wait a minute. In this picture, this node, that node, and the one wherever this comes from, those are exactly the input to that by substitution, aka critical pair lemma, aren't they?
Yes.
So what are you saying about additional pieces?
They're the constructs, not the inputs. That's the key difference, right?
Well, the only thing that you need. Go ahead.
No, please go on.
Okay, the only thing that you need is like each event will contain a set of positions that was this event like acted on. So like in the case of substitution, it's just one single position where the substitution happened. In the case of critical pair lemma, it's the position and all the variable substitutions within the expression, because all the variables can be affected. So it would be a set of positions. So just given this set of positions for each event, we can just determine the causal structure simply from those.
Yes, so Nick, that's completely true in the case of substitution lemmas, that in that case, it's just the same as ordinary multi-way causality. The point I'm trying to make is a more subtle one, which is that critical pair lemmas produced by an equational theorem prover involve essentially the input for a critical pair lemma does not necessarily have to be an expression that exists in that proof graph. You'll see that if you look at any proof data set, you'll see a matching, you'll see that the sub pattern for a critical pair lemma doesn't necessarily have to be something that already exists in the proof graph.
Well, it's still a part of some other lemma or an axiom.
No, not necessarily.
What do you mean? It is, because it's like I turned this thing apart. I understand it. It's like, yeah, it should be. It's like how find replace path works. It's like it turns all those critical pair lemmas apart in terms of positions and reconstructs the path.
Okay, maybe we need to get onto other parts of the agenda. We should probably have set up a separate custom meeting for this theorem proving thing. I mean, there's more to discuss here because, again, I mean, you know, let's not get into this here. Let's put this in the next multi-computation meeting, because this is about to get really complicated as we start talking about, yeah, the relationship between this and, yeah, let's not do this here. So I think we should move on. And
I know I've been asking this for a while, but is it possible to get added to those?
To which? To the multi-computation thing?
Yeah.
Sure. You're very welcome to. Yes, absolutely. And maybe my new assistant infrastructure will help do that. Yes, somebody who's Avery, you can do that.
Yep. Yep, I got it.
It's or just feed it to the scheduling queue.
Only one minor comment before we leave this. So together with the proof data sets and the proof graphs, we also had the proof functions. And I think it's there where we always had more problems to represent this by substitution. So that would be an important thing to discuss too.
Yeah, how is that done, in fact, right now? I mean, look,
we don't have a way. Somehow there is some sort of jump in the argumentation when there is a critical pair lemma here.
Right, but this is precisely the point I was trying to make earlier. So a critical pair lemma, if you have a critical pair of the form XY, all you're doing is you're saying there exists an expression, a common expression such that application of, one rule application yields X and there, one rule application yields Y from some common expression Z. It makes no claim as to whether that common expression Z actually exists in the proof up to that point. There, of course, in most cases it does, but that isn't guaranteed.
I don't understand this well enough, but this is an interesting, I mean, look at this. This is exactly showing us the kind of thing that we need for the representation of sort of the steps in a computation. Because this is, we could have something like this that just shows us the evaluator running and doing transformations, right? Which down value rule is being used and where it's being used.
Right. And this part works very well. Now, the thing is that when we write these critical pair lemmas, the expression they contain comes somehow out of the blue. And it would be nice to have a way of incorporating how that was created.
Right.
That's what I exactly do for the find replace path. So it works for both substitution and critical pair lemmas.
Can we see a find replace path just for a second? Can I do that for this particular thing here?
If it's not broken, yeah. It's already in the repository, but it's experimental. Yeah.
So you're saying resource function of find replace path, which is misnamed, if I might say so. Which order does it take its arguments in?
The same order. You can even feed it the proof object.
Okay. Okay. All right, fine. Why is it grinding for so long? Does it have to do a lot more work after find equational proof?
Well, maybe it just uses a bunch of dependencies and it's loading it.
I see. Okay, but it's going to show us in the end a path from here to there.
Yeah, if it works.
Which it didn't in this case. Okay. All right. Let's tackle this a different time. Okay. All right. I think we should go on to our next topic, unless anybody has anything about this right now. I mean, look, I do think we just need to get a little bit of a design refresh for these and have them correspond to these and so on. And I know we also have this mechanism. What is it called? Is it weighted proof graph? Or is it proof?
It's either weighted proof graph or proof graph weighted. I can't remember.
There we go. Yeah, you see, that's nice, but so is this. I mean, but they're both interesting representations. So we probably need to redo the property list to deal with that. And okay, just one general knowledge question. Okay, if you look at other theorem provers, so we've got here an equational theorem prover, and if I were to try to represent, okay, two questions. If I were to try to represent something from the MetaMath system, something from Lean, something from Coq, what would they look like, and do they have a correspondence to this? Anybody want to? Nick, can you say from? Go ahead, Jonathan.
No, go for it.
I was going to ask Nick about MetaMath to begin with.
Oh yeah, I do have some token event graph for the MetaMath. It's like a little bit different because those substitutions don't have just like a target and construct and your rule. It can like make, it's just the usual substitution, just replacement of variables. So those events gonna have like multi-inputs just for each variable in the expression. And I think that's the only difference.
Okay. Although they cannot replace subtrees, they can only replace variable locations.
Right.
And on the graph, you will see them. But it's interesting that that is more like our evaluator, just replacing. Is that right? Just doing transformations in which pattern variables are instanced. Now, okay, so talk about Lean, for example. Is there any analogous graph for Lean? There has to be.
I think you can make it like for any arbitrary program or code running, because it's just any substitution is just function application. So, and Lean is highly functional, so it's just a bunch of function applications. So you can turn it into substitutions and so on and make a similar graph.
Well, but so you're saying also the execution of JRandom program is also representable by something like this, except that most programs, I mean, this is where the whole multi-computation story of whether it's just a single sequence of substitutions, so to speak, or whether it has this feature that it has, intermediate lemmas and so on comes up, versus the whole question about whether you're recursing through expressions and so on. It's complicated. Any just final comments about the relationship to other proof assistance and theorem proving systems? I mean, would we expect that in general terms that we could take a proof assistance, a proof represented in a proof assistant and make a graph out of it? No.
Sure, why not?
Fair enough. All right. Okay. Let's move on. So, Jonathan, you're welcome to stick around, or anybody who is here for theorem proving alone is several people, maybe including Jonathan, might be interested in the aware idea. But let's see if we can grind through conform dates quickly.
Okay. So this is a relatively self-contained function, but it's come up a couple of times. We were talking with Gosha and Eduardo and some of the work that they're doing for the time series revamp. And what we want to have is a function where you can put a collection of dates and have some control over what you get out.
I agree.
Yeah, the main focus, I think, is on date objects, which have the most parameters. But conceivably, if you put in a mix of different formats, we could spit back out date lists or absolute times or date strings. If you know.
So why isn't this just data object of? I mean, data object of each of these things individually. If I just map data object over this with granularity month, will I get that result?
Yeah, you'll get the same result.
Okay. So what's the difference between that and this, so to speak? Is it auto-conforming things, so to speak?
Yeah, so the single argument form will auto-conform granularity. It can also pick out different parameters for calendar type, time zone, time system, date format, etc.
Okay, so which calendar gets to win?
So by default, we look and see if there's a consistent calendar. If there is, we keep it. If not, then we need to have some heuristic that's either most frequent or defaults to our default calendar. Right now, the implementation I have that's in prototype builds just defaults to the Gregorian calendar. If you don't,
I think that's the right thing to do. I mean, I think that's the sort of took over the world over the last 300 and 400, whatever it is, years.
Yeah.
Okay. But now what about granularity? Do you go to the coarsest granularity or what?
We currently go to the finest granularity since it's the least destructive. So if you have years, months, and days, we will conform them to days because we don't lose any extra information. But you could obviously specify it, or we could do, I don't really like the idea of looking at like the most common one, but that's another option for whatever we want the heuristic to be.
I mean, I feel like if you're being really rigorous, you would do the least specific one, but
I would think so too.
Yeah.
I can imagine dumb problems though, where it's like, you have all this data and then you have one data point that's like granularity century, and then all of a sudden your data disappears.
Yeah, I was thinking, I have a bunch of historical figures. I have their birth dates,
yeah, except one of them is unknown to, yeah, that's a good point. One of them is, okay, but what should you do?
But it would be pretty, I don't know, it would be pretty confusing. I mean, I think it's kind of a problem though, if you have your historical birth dates and one of them is only known to the century, and then all of a sudden now it's in your data down to the instant. Like, yeah, I feel like this could lead to kind of weird problems.
Right. I mean, that's part of the reason that we have different granularities in the first place, is that we can have dates of differing resolution. But if we're
so let's go through the use case for conform dates.
Mm-hmm.
So, for example, you want to do a time series computation, and you've got, I don't know what, Democritus, whose date of birth is only known within the decade or something.
Mm-hmm.
And what are you supposed to do in the time series? Do we have anybody from the time series group here? No. But that's the question, is what do they want to do with that? Because I can imagine that they can do something different. If you're trying to say, what was the total density of philosophers alive at any given time in history? Okay, and Democritus is unknown to within 20 years, let's say, when he was born. They're going to have some way to deal with that in their time series analysis. And it's probably matters that one is uncertain, rather than nailing Democritus to a particular year, for example, or worse still, puffing out everybody else so that, we don't know when, Nietzsche was born or something, which we surely know to the day.
So maybe one question is just, right. I would imagine that, if we do everything right, then you should never need this function, because every function that takes dates should take any date and should kind of treat it equally and so on. So I'm not sure. I mean, it seems like this would be a useful internal function, but I'm not sure when you should ever use it, you know,
So
as a user.
we have conform audio on conform what is
Images.
image.
Conform images.
Yes. So I think this
That's
is
very
model.
different.
Mhm.
I mean,
Like, I think
conform,
those-
yeah.
Well, I was just gonna say, I mean, I think like conform images and conform audio, those are basically for machine learning, and they're just for making sure that, you know, the dimensions and stuff are all the same.
There might be similar problems, like they are given in different color spaces, some providing more bits and other less. What do they do?
I'm not sure.
Sure, but I feel like, I mean, but those are already doing pretty destructive things. I mean, you know, if you call image resize on an image, you're already, you know, the result is only an approximation of the original image, you know, no matter what. And again, I think the only real use for that is some case where you're basically grinding up a whole bunch of images together, you know, as in machine learning and some image processing applications. But in both those cases, you don't really care about the details. I feel like dates, though, are exact things. You know, it matters whether it's, you know, if it's off by a little bit and so on. So I think it's a bit different.
Mm-hmm.
Why don't we?
And also, of course, you know, image functions, if you call image add on two images that have different dimensions, you get a weird result. But if you call, you know, subtract or date plus or, you know, whatever on two dates with different calendars and so on, then it should work perfectly. So I don't think there's, you know, with images and audio, there's like a fundamental problem of like, if the dimensions don't line up, it's unclear what to do. But with dates, it's totally clear what to do.
Let's push back and ask the time series people to tell us what they want this for. Okay. Unless Nick, unless you have other things.
No, I mean, I think the other benefit of this is efficiency. If you're standardizing a bunch of dates, if I have dates that are in a bunch of different time zones and maybe different calendars or time systems, we can basically batch process and do all of the time zone conversions, all of the dates.
Okay, well, I don't really have a problem with that. I mean, that seems perfectly sensible. The issue is with granularities.
Okay, yeah, granularity I think is the case that's a little more complicated to figure out what the appropriate thing to do is. So I'll check it. We have a meeting with Gosha and Eduardo.
Fine. And I could imagine a thing where what one wants is something that says, you know, something like what the target granularity should be.
Mm-hmm.
Because, I mean, one issue is, by the time we're recording, you know, to the minute when Julius Caesar was born or something, you know, it's just nonsense. But one has no idea, right? Mm-hmm. And yet, and I can imagine a situation in which things are being stored at instant precision, but where that's just goofy.
Right.
I mean, and where it'd be useful to be able to do this. So I mean, that would be my take is time systems, you know, calendars. Yes, those are all worth conforming. They lose no information.
Yeah.
All right. And push back and find out what the time series folk need this for.
Okay.
All right, I want to talk a little bit about aware because we've I think it's I mean we can get to that, but I'd like to look at aware for a bit.
Okay.
What do people think of the name aware? Is it insane or not? Let me remind people what
it's
aware
cryptic,
is.
But
I'll come up with a better one. I had a big long list of them. I mean, what it's doing is it is providing its most default case is things like this, where we are lexically looking inside a pure function here to find what aspects should be picked up. So, you know, one thing we're clearly going to need. Okay, so what about the discovery interface of what is available at that place? So in other words, you're inside a map, you're at level 17, what can you find out? See what I'm saying? How would we determine that? Because it's only known at, well, it may not be only known at runtime, it might be known at previously, right? In other words, if we ask the question, and perhaps this is a code assistance kind of thing. At this lexical position in my program, what possible, like here, I could imagine some kind of autocomplete mechanism which shows me what set of properties I could request there.
In take largest, we do all. So we have this notation of arrow all, and then it provides an association with all the properties and their values.
Sorry, for which?
Take largest list arrow all.
Yes.
Now, in this case, when you just say hash, though,
in the
that would
aware.
be the same as all. Yeah.
Oh yeah, you're probably right. Yes, you're right. Yes. Okay. So then, what you're saying then is, here, let me just. What you're saying is, okay, so hash alone, aware of hash, and then that there, hash is the full association. And which, so your code could then say, it could pass that hash down to some other function, send it off somewhere. It could pull it apart separately, right? Now, I mean, much like confirming close, we might want a version of this. I guess this is the version that is non-lexical. You pass in hash, and then it can be taken apart anywhere else. Does that make sense?
As in, it actually, it has to construct the association if you just say hash. And
that's correct. And so then you could send it off. I mean, if what you had written was aware of f of hash, and then your actual, examination of the thing happens in some other function that is not lexically connected, that's all okay, because it's got to construct the thing to send it off there anyway, to create the hash there. So then the idea would be that, aware would have, in this case, it would lexically find things. But again, we need the discovery interface. How do you know what the properties are? Because we've got lots of potential properties that can work. For example, I've got another one here. So for, map related is another property would be something like, how do you get those things? I always forget. Is it tab?
It's asterisk.
Oh yeah, right. I should remember that. Okay, so map related, we've also got things like, I don't know what we want to call it, serial number, or, you know what I'm saying, which is i.e. Which, what's
I have no idea what you mean by serial number.
What should we call it? It's the, okay, if map
like traversal index, like what index in the traversal order?
Yes, that would be a way to say it. Traversal index. I mean, that's quite obscure too, but I mean, but you understand, etc. You understand what I mean there. That is, if this is which iteration number, like you've called this function, how many times have you called this function? How many times has this function been called before? You see what I'm saying?
As in, it's it's the index in the order that map hits things.
Exactly.
Right.
Exactly.
Which in the case of map at level 1 is
the same thing as the index.
Yeah.
I have a hard time imagining being interested in that. I mean, most of these other things, I've encountered situations where I might actually want that information. I'm not sure I've ever encountered a situation where I really wanted to know that.
Bet you have it. It's for example, if you want to give a unique index to everything, this is something that will be useful. I've certainly wanted this in pseudo meta programming type situations. But in any case, I mean, I
think that the basic thing though is that there probably is there are probably a whole bunch of pretty obscure keys that might be useful once in a blue moon, and ideally those should be free to add.
Yes, quite.
I mean, it might be worth doing some. I mean, right, depending on what optimizations we're going to have in this, it might be worth doing some benchmarks to see if like there's a, you know, if there's a significant performance hit to having to construct, every time we add one of these keys, if it's going to be a bit of a problem.
Exactly. Yes. But I mean, so what?
Can I go back to the question at the top? Do we want and need a two argument form? And I think the answer to that is yes.
Yeah, I think the answer is yes as well. I think it's useful to have a two argument form where we're affirmatively saying, for example, if you're passing the hash.
I just don't want to be forced to use a pure function of an association every time. Well,
quite. I mean, in this case, look.
Like in those first two cases, you don't even want the ampersand. It's just aware of index comma f/at.
That's correct. But that's the pure index. It's not going to get the expression in that case. So I mean, the map, map index.
I proposed that if you don't have a list, that it gives that as an additional argument.
Oh, that's a good idea.
Like map index.
Good idea. Yeah, it's a good idea. But I suspect
maybe you should write that down so that we don't forget it next time.
Yeah. Okay. So then let's say if
there's the tree meta applied page, but I haven't made the page or anything for aware.
Okay. The second arg is not in a list. Treat it as expression, comma, arg. Right?
Yep.
That's nice. That's really quite nice. Okay, let's take a look here for 1 second. Just look at this. This was my meandering collection of possible names. And names like sponge are not serious.
What about giving or providing or taking?
Taking, definitely no. Because take is a,
something about the act of giving arguments.
I think that's really obscure. I mean, I think that this is going to be the case you see most often in code.
Is it giving or receiving?
Yeah, well, yeah, I mean, that's receiving, absorbing.
What's doing the giving and what's doing the receiving? Yeah.
I think it's more that this is receiving.
Mm-hmm.
About supply?
No, because this is the thing. Remember, what we're really wanting to say is there's a porous membrane. There's a collector that is collecting things. That this thing here is having things absorbed for it from the environment that can then go into this.
Why isn't it supplied?
That's interesting. Okay, what would the sentence say? This would say something like, represents. Okay, so supplied of f. Well, supplied of expa. No, it's probably a func. Represents a function for which situational variables have been to which situational variables have been supplied. I do like the term. What do people think of the term situational variables?
I do like supplied, and it's very close to applied, which we have used for other wrappers.
Fair enough.
I might use contextual rather than situational.
Okay, fair enough. That's better. All right, so then...
What about supply?
I don't think
It's a
that's
little
right
weird.
because it's because it suggests it's going to return something and do something.
I'm not totally sure the use of past tense there is totally, I guess with like curry applied and things like that, I guess it's maybe consistent.
Right. And I think supplied of a function, comma, index looks quite lovely. That works well, don't you think?
Yep.
I forget last time, I think we also talked about whether the arguments should be at the beginning or the end.
I know, but I'm convincing myself with this, with Ian's kind of thing with the elision of the, where this is going to be a second, by default, this is going to be the #2. It somehow feels better to come second, I think. Even though, even though these things are ultimately going to be function arguments, which in a sense come first in the function declaration.
Right, well, there was that argument, and there was also the fact that if you write a longer function, it's a bit weirder. Like you have to find.
I see.
Yeah, and it might be nice if also, if you say supplied a function blah blah blah, and then you can see that, well, my function takes 3 arguments, and I'm supplying 3 arguments, and now I can see what my function arguments, what they correspond to in the supply, because it's right there.
That's reasonable enough. That's reasonable enough, because then a not unreasonable thing to do would be to say supplied of index, expression, level, and then you would say XYZ function, blah, blah, blah. That's rather beautiful. What do people think of that?
That reads all right to me.
Okay. All right. Well, supplied is a decent name, I think. See how we feel about it. It's less weird than aware. Definitely less weird. Sander has made some comments here, commenting on the discussion that we were having before about traversal index. Yeah, actually, I'll tell you a very good reason for using traversal index. It's for progress monitoring. Right? I mean, and we also want things like, fraction complete, or elements, another thing would be, elements processed or something. Another thing we probably want, which is
fraction complete would require 2 passes through the expression, which I'm not
unless
sure
we happen to know, unless we know. See, because we might know in some cases, like if it's mapping over a list, we trivially know. I mean, we're perfectly.
So, like, if your level spec has a negative level, you are going to be forced to do a traversal of the entire expression.
But be that as it may, it's still, I think it is no dishonor, and we're going to need to deal with that case. Where, supplied with a get this at all costs versus if you happen to know it, return it. Distinguish contextual variables that are naturally known versus have to be mined. We don't really have an analog of that anywhere else, do we? But we certainly could have. I mean, that concept of, do you happen to know it? Well, like fraction complete, you could say, if you happen to know it, you can display a percentage, otherwise show a barber pole. Does that make sense? I mean, you must have something like that in the progress monitoring framework, don't you? Itai or others, can you comment on that, please?
I'm sorry, I was momentarily distracted. What was the question?
The analog of things, okay. Fraction complete or total elements might be trivial to determine by being naturally known, or it might be something you have to mine for. I'm saying in the progress monitoring framework, you must know those kinds of things.
I mean, the person who's monitoring the progress has the responsibility of supplying those. So,
okay.
Right. And so in some cases, we do know, right, because, right, we're doing an iteration over something. And so we just know ahead of time, right? But in other cases, then, right, like a download size, if the web server is nice enough to give us the size of the file ahead of time, great, we can say this fraction complete. But if it doesn't, we can just say, we've downloaded this much, but we have no idea how much is left.
Yeah. Yeah, fine. But I mean, there may be cases where it is very cheap to determine the total and others where it's not. By the way, something we have not covered here is aware or supplied in a rule. Right, something where, you know what I'm saying? I mean, is this, do we expect this to just work?
I think we talked about that last time, and it was there were some issues. I don't remember exactly what it was.
Well, we have notes from that, but yes. Well, but I think we need to make sure we cover that case.
But by the way, maybe it's just a point from a bit ago. You know, I just did some tests about, you know, if you construct bigger associations, you know, how long does it take? And you know, if you're mapping over something, you have to construct an association each step. And it does seem like the time it takes does go up linearly with the number of keys, which is slightly annoying. Okay. Right. So if we add, you know, 25 random keys, it will be slower.
Humph. Well, so if we add 25 random keys for the case of hash, so to speak.
Yeah, yes, only for the case of hash. I mean, assuming that we can have these optimizations, but yeah.
So then the question is there any lazy way to do this? I mean, we do know where on the stack the thing was. Is there any way we can crawl back up the stack? You know what I'm saying? In other words, if we passed some kind of stack pointer to the receiving function, is there any chance to go back and look? Any thoughts on that?
I don't know what you mean. Do you just mean like you don't actually have to construct the association for the...
That's what I'm saying. Yes. You keep the stack pointer where you made that call. And then if you ever need to know things about the state of the world when that call was made, you somehow go back to that position on the stack.
I feel like that's not the issue. I mean, the problem is more just the fact that, you know, if someone asks for hash, they're going to get an expression with head association, etc. You know, unless we want to change how associations are represented.
Yeah, all right, okay.
There's a certain cost in making it. So,
well, we don't have the notion of a lazy association, basically.
I mean, have the notion rule delayed, but that's different. But yeah.
Well, even that might be. I mean,
like
it might
be association where you don't even know what the keys are.
Right, but it might be easy to make the backbone without putting data in. It might be that we could make a single backbone somehow. I mean, it might be that with compiler technology, for example, we could make something where the backbone is ready and has to be filled in. But can we look for a second at this rules case? Because here, I mean, we need to inventory it, and maybe this is something Ian could look at, which functions can take sort of supplied situational, contextual, whatever we want to call it, you know, can have contextual variables. Right. So for example, one thing I wouldn't be certain about, let's take a function like, so, let's say other functions. Okay. So for example, could outer be supplied with, and then it's a little bit complicated because it's supplied with index 1 and index 2. See what I'm saying?
The index is a list.
Yeah, the indices of the or position 1, position 2 of the things, right, that become the arguments. Actually, in this particular case,
maybe instead of position 1, maybe I mean, I would argue it should either be, if it's always going to be 2, it should probably be left position and right position or something.
But not.
Otherwise, it could just be indices, and then indices is a list.
Fair enough. Positions or something. Yeah. Yes, fair enough. Okay, but that's a special case for outer. For inner, for example, it would be more like, position. Well, it will be like index 1, index 2.
Maybe there's a large class of functions that act on like expressions or trees somehow, but
okay, let me give you a more extreme.
It's hard to imagine a limitation of what supplied could do in any function. Supply something about.
Well, here's a case. Where which we had before. We had this notion of a supplied value, well, a where value, but a supplied value would be something like sine x plus, and then something that depends on its elements processed or something like that. How many evaluation count, or something like this. I mean, that's probably crazy, but it's just something to raise here. And I mean, we could have the notion of a supplied value, which would be something that would pull itself from the environment. Okay, is this a possible thing that just in an expression that one could say something like, well, this may be hopeless.
So can you open the page for vertex shape function?
It's not a happy page. All right. Yep.
I'm interested in the arguments that are given to the function.
They're grotesque. Where are they?
Well, I'm just saying those could be named things that.
Yes, they could be.
So I guess I'm just saying this is just a very broad concept that could conceivably be used for almost any domain specific thing.
No, I agree. I think it's a useful general idea, which has, because there are things that you might, I mean, this vertex shape function
like a XY coordinate for a center point is just not going to make any sense in map.
Of course not.
Perfect sense in a vertex shape function.
Right. But now the issue is a lot of things where you might provide a supplied in the right-hand side of a star function type option. Right, that's the notion there. Where it's a thing that might be useful for that function, like, nearest function might, no, that's a bad example. What's a good example? Something in feature space plot, a feature extraction function or something would have both the main payload and could potentially be supplied with other things as well. Like, what's the total number of objects that you're looking at? Those kinds of things.
Mm-hmm.
I think it's a fairly general concept, which is good, but I think, our original reason for introducing it, among other things, has to do with annotating how,
so wanting the position is super common. Like we may even want like a position applied specifically just for that case, because we have map indexed and we don't want indexed versions of everything.
Right. So that's okay. So there's a possibility then of position applied. Well, we could also have index applied. I agree. It's awfully confusing that map index takes, although I have to say, I think the use of map index will just plummet with these kinds of constructs. I mean, I'd much prefer to use these constructs rather than map indexed. By the way, Avery, could you merge these things back into the notes, the stuff about aware back into notes, into another multi-computation note thing?
Yeah, like number 9.
Yeah, for example, yes.
Yes.
Okay, we don't have much time here, but if there's anything here that we can just look at quickly.
Yeah, I mean, same as Q is pretty straightforward. We have equal to, we don't have an operator form for same Q. Maybe there's a case for it. It's relatively
because the one
common.
argument form is otherwise just returns true.
Yeah, for singleton inputs, it returns true.
Which was kind of stupid, but
Well, I think it has to do that because it's var args.
Yeah.
Yeah, I agree.
yes. It's okay. I mean, this is okay. Anybody object to this? An operator form of same Q?
It could be very useful. I mean, it's sort of a shame that it has to be, it couldn't be same to Q because a lot of these other ones are 2, but I guess like greater and less or like greater than, less than. So yeah, I guess it's consistent.
But it needs a Q, right? As opposed to just same as.
Well, arguably it should be same Q as, but that's a little funky.
Well, what about same as?
I mean, the real problem is that equal is equal and not equal Q, right?
But it shouldn't be equal Q because it just sits there. I mean, it can't be equal Q because it's got this.
Right. I mean, I guess, yeah.
But what would there be a non-operator form of same as? Is there a non-operator form of equal to?
Don't believe
No.
so. Yeah.
Well, then I
Actually,
think
is there a non-operator? Is there a non-operator form of greater than? Or is there an operator? I'm wondering why do things like greater than exist when I don't think greater can take one argument?
Are you sure that greater can't take one argument?
Not.
Yeah, see, it's got that. That's why we had to do that.
Okay.
By the way, Dan on our live stream is asking about the operator form of part. Why isn't that? Wait a minute. What?
Arguably, it's query.
That's obscure. That's obscure. And I mean, extract. Does extract have an operator form?
Yes.
Yeah.
It does.
Oh, Jonathan is pointing out that there's a tally production. Slice.
Again, though, I mean, as pointed out before, if you replace every instance of slice there with query, it'll also work. Would extract work, actually? I don't know what, I mean, you can use span and extract specifications, right?
Yes.
And extract would also work in all these, I think.
For some reason, I never think of the operator form of extract. I mean, I have many times when I use, #2 ampersand, which I admit is shorter than extract2. What am I saying? I don't mean that. I mean #2. Right, which could perfectly well be this. Well, I think same as is the thing we should consider there.
Okay.
Do we need an same as?
Probably.
Unsame as is a little bit ungrammatical though. Like unsame from or something. It's kind of, yeah, it's a bit weird.
Is unsame even grammatical?
Not really. Well, we should think about that. Same as seems like a winner, but what on earth is map level? Map's a function of a data at a specified level. So this is basically dealing with the operator form. It's a different operator form of map. Right?
Yeah, I mean, you can see in the first example, it's basically generating a query function. And there's an analog to query is the final example there, but it's maybe something that needs a little more time to look over.
It needs more effort, yeah. I mean, this doesn't seem like an obvious winner. So select itself does not have a level spec in its current form.
Right.
Instead, it has the I think, much less useful thing of how many things do you want to return.
Oh, I don't know. I find that quite useful.
I don't think I've ever used it.
We'll compare this with cases.
Which takes a level spec, yeah.
And then an in.
I've used that count. I mean, if I just don't want, I want to find one that satisfies something, and I don't want to go through the whole list.
That's called select first.
No, you still want to do a select, but you want to specify a level spec.
No, I know, but this is the new thing.
I'm complaining that right. Yeah, I mean, it seems like in retrospect, the right thing would have been for it to have the same argument structure as cases, because it's easy to say level spec 1.
But we could perfectly well say, I mean, for example, we could have a 4-argument form of select. No, we could not.
We could.
That's what we did for tree select, which is not precedent.
Say that again.
I said for tree select, we added a 4th argument with the level spec, but I'm not saying that should be precedent for this.
I mean, it's just a little tragic if it has the same exact arguments as.
I know, but the two things
version
are in the
of
opposite
cases,
order.
Yeah.
That's awful. Is it obvious what select does? Because it's like you've shattered the structure. What do you return if you're not returning the whole thing? See what I'm saying?
I think it's the same as mapping select over it. If you say select at level 2, I'm not sure exactly if you did select at like level 2 without braces around it, if you know what I mean. I'm not sure what that would mean, but
because cases is clear what it does, because cases are going to return a list of results. So I think
so does select preserve the head? Is that?
Well, that will be the issue if that's the case. I don't know if select
I think so.
does.
I think select is just, if you select at level 2, it's just mapping the select over it. Now select at level n is just map of select at level n-1.
Look, this is the issue.
Mm-hmm.
What?
Well, that it preserves the head. I mean, cases does not preserve the head.
Well, what's the problem with the preserving the head? I mean, if you have a list of lists, that'll do exactly the right thing.
See, that always just gives the list.
No, I don't understand what the problem is here. I mean,
The problem
you're
is that
worried.
if you
What
have
you want is you want select to, you give it some big deep structure and then it returns a flat structure. But I'm saying I don't think that's what you want. I think what you want is for it to retain as much structure as it can.
I understand that. If they're lists, it's okay. You're just making more ragged lists. But let's say the things that you're selecting into are functions that have positional arguments, and you just shattered your positional argument structure by doing a random select with some criterion.
But that's the case with single argument select too. I mean, I think select, yes, technically works on non-list things, but it's a bad idea. Like it's rarely useful.
Yes, I realize. Right.
I think
Or
there
it's
may be an
rarely
issue with
used.
sorry.
Go ahead. Sorry.
I think there may be an issue with preserving heads, since if you have a level spec, you may have things that are sub-expressions of other things that are getting selected.
Oh, that's true too.
Not selected.
That's true too. Whereas cases, it doesn't matter, because cases, you're just going to unravel the thing and return all the pieces. We should wrap up in a second here. By the way, I just question. We have a Jonathan has been working on a category theory framework, and we're going to meet about that. And who here, who isn't in the obvious list, wants to be included in that discussion? That's a disappointing.
Am I on that list?
I'm not sure you were, so you should be. Okay. There's more enthusiasm than is indicated by lack of people clamoring to be part of that.
Maybe everyone's already on the list.
Yes, we are in that list already. Yes.
Okay, fair enough.
Mhm.
Good. All right. Okay, we should wrap up here.
Is that the thing happening this Friday, or is that something else? I was added to a calendar event with you with no title.
There's one in my calendar with no title as well. So
okay,
I don't know what it is.
maybe it's not that.
I haven't a clue.
Someone wants us to talk on Friday.
It might be. I don't know. That's actually a new thing. I've never seen that before. Okay, we're in a transitional phase in terms of handling my calendar. So okay,